All right, so we pick up here now, and we have now an investor who's going to invest for the long term. I assume, right? We'll say multi-year, and here is him paying the his initial and buying the stocks. Right? Again, it's negative, right? At the present. Here's the dividend, and at some point he gets, he continues to get dividends, which go up or down. By the way, dividends are not always constant. And here he is when he sells. Again, doesn't have to be at a profit. It could be a loss too, right? So here is the equation that shows you that timeline, and we're getting the present value back, right? Based on the cash flows. So this should be a familiar concept to you. These are cash flows, right? Year one, year two. See, there's a two there. So as a 2-year investor, we care about the dividend and stock price in year two, but these terms do not appear in equation 9.1. Okay, does this difference imply that a 2-year investor will value the stock differently than a 1-year investor? And the answer is no, of course, right? A value is value, right? While a 1-year investor does not care about the dividend and stock price in year two directly, she will care about them indirectly because they will affect the price for which she can sell the stock at the end of year one. For example, suppose the investor sells the stock to another 1-year investor with the same beliefs. The new investor will expect to receive the dividend and stock price at the end of year two, so he will be willing to pay this price here, P1, which is this term right here, on the right-hand side of the positive sign. Everyone see that? This is what he will pay for the stock. So if you substitute that expression for P1 into equation 9.1, we get the same result as shown in equation 9.3. There's equation 9.3, and you can clearly see it works out to the exactly the same equation. See that? So they've got to worry about the prices going forward. Thus, the formula for the stock price for a 2-year investor is the same as the one for a sequence of two 1-year investors. And again, this for non-arbitrage, right? Law of one price, everything's got to be the same, right? All right, so this introductory stuff we just did takes us to the dividend discount model equation. And this is a model that will value shares of a firm according to the present value of the future dividends the firm will pay. So we're going to generalize everything we saw. So here's equation 9.4. And you can see they're taking it for each period and saying, well, this is what the stock is worth, even though this is not taking into account supply and demand right away. When I buy stocks, I don't go to equation 9.4, and I don't solve this equation. So this is a single N-year investor, right? So you notice the word single here, right? Who will collect dividends for N years and then sell the stock or to a series of investors who hold the stock for shorter periods and then resell it. So supply and demand is a real big part of this. Note that equation 9.4 holds for any horizon, right? Any horizon N. Thus, all investors with the same beliefs will attach the same value to the stock, independent of their investment horizons. So beliefs are something, how do you measure same beliefs, right? It's all psychological at that point. That's a big question. Behavioral finance is an important topic which takes into account beliefs. How long they intend to hold the stock and whether they collect their return in the form of dividends or capital gains is irrelevant. For the special case in which the firm eventually pays dividends and is never acquired, it is possible to hold the shares forever. Right? Technically, it is. Consequently, we let n go to infinity and write it as follows. So this is the dividend discount model. Now, there's a lot of stuff going on here, right? To get you the price. Here's the price. You don't have to look at this, and this is simplified right here. This is simplified. Well, it highlighted everything, but this is the simplified portion, and you'll notice it goes on forever. The sum of the dividends forever, and there's no reason to believe that the your cost of equity capital is going to stay the same either. So this is a very general equation that, to be honest with you, people don't use. It's just builds up the theoretical underpinning for stocks. Okay, so that's really what that does. So let's apply the. So if you look at the dividend discount model, the math is relatively simple. All right. And if you go back, you'll notice this is a perpetuity, right? It was going to infinity. Here, let's go back for a minute. Let's go back for a minute. As soon as you saw that this was an infinite cash flows, that should have told you the word perpetuity should have popped in your head. Okay. So we're going to look at that. So that means if it's a perpetuity, we can simplify that equation. And so here's the cash flows going on forever, dot, 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 in perpetuity. And because the expected dividends, and here's the words, are a constant growth perpetuity, which is not always true, right? The cost of capital will vary, and the growth rate will vary. We can use equation 1 to calculate their present value. We then obtain the following simple formula for the stock price. So you'll notice the growth factor is in here, right? So here's the constant dividend growth model. The value of the firm depends on the dividend level for this coming year. Notice that divided by the equity cost of capital adjusted by the expected growth rate of dividends. Here's the expected growth rate of dividends. All right, so this is a nice simple problem they just show you for Con Edison here. And you know, the math is pretty trivial, right? You just hear they're just popping numbers in for you. So they rearrange the equation. They take the equation 9.6 and rearrange it to get you the cost of equity, right? And all they're doing is just it's the same equation, and here's the growth rate, and here is the dividend rate. Okay, so this is the capital gains on the stock, right? So again, it's the same equation of same as 9.6, just rewritten for your enjoyment and pleasure there. All right. All right. So the share price increases with the current dividend level and the expected growth rate. G, to maximize its share price, a firm would like to increase both these quantities. Often, however, the firm faces a trade-off. Increasing growth may require investment, and money spent on investment cannot be used to pay dividends. All right. So we can, you can look at insights into this trade-off, and there's a whole section here which I'm not going to go in, but the theory of investment value. And this is a famous book from 1938. So you can read if you want. You can get the book, and so corporate finance has been developing over 100 years, right? All right. So there's another model of growth. Uh, if you define a firm's dividend payout rate as the fraction of its earnings that the firm pays as dividends each year, then we can write the firm's dividend per share. So here's the dividends per share. Earnings of the shares outstanding times the dividend payout rate, and you see this all the time actually in real life, right? They'll give you the basically the earnings per share and multiply by the dividend payout rate. So they're just showing you how they can increase its dividend in three ways. Increase the earnings, right? If this goes up, this goes up. Increase the dividend payout rate, or decrease the number of shares outstanding, right? Which they buy back shares. Companies will buy back shares, and then that dividend, because there'll be less, and then they could possibly increase the dividends that way. So basically, changing the earnings can change, right? Either make a new investment and basically get a higher return on that new investment, or you can basically have a retention rate here, right? Which is the fraction of current earnings that the firm retains. So the earnings growth rate is the change in earnings divided by earnings, right? Which is equal to the retention rate times the return on the new investment. They take this equation and they substitute equation 910, which is right here, into equation 99, and combine them basically and come up with this new equation. So if the company chooses to keep its dividend payout rate constant, then the growth in dividends will equal growth of earnings. So G then will be the retention rate times the return on the new investment, which is equation 912, right? So if they keep the dividends constant, then that's got to equal the growth in earnings. So if you take a course in entrepreneurial finance, you'll learn this term called a sustainable growth rate, and this is the rate at which you can grow used only retained earnings. All right, so whoops, what happened here? Hold on. The sustainable growth rate. All right, so around 12 minutes in, I will pick up over here, and then there'll be a couple of nice short dividends models here. All right, videos we can watch from the publisher.